Okay, so continue. So the basis vector and image. So this is already discussed. So this is the where you will get the inverse transform equation. Okay, where TUV is the transform image. So this is the basis of the inverse process. So what you will do is to inner product the TUV. Remember, TUV is the transform image with the same basis image. Okay, while you do the transformation. Okay, then you will get the IRC. So the original one. So this is the transform equation where B minus 1 RCUV represent the inverse basis images. So in many cases, so the inverse process will use the same as the forward one. Okay, means that you will use the same basis image while you do the projection. So you will get the inverse image. For example, this is the TUV. So TUV is the output of the projection, okay, the frequency domain, which you get 11,153. So you will, to get IRC, you will project again the TUV with this transform image. So if you look at the basis image just now, so the basis image for the inverse also using the same, where you will project the TUV with the basis of 0, 1, 0, 0, basis of 0, 1, basis of 1, 0, and basis of 1, 1. Okay, so you will do the projection 11 multiplied by 1 plus 1 multiplied by 1, 5 multiplied by 1, and 3 multiplied by 1. So the addition, the inner product of the first T00 will be the first of IRC 0, 0. Okay, which is 20. So for 0, 1, okay, means 0, 0, 1 is this 1 multiplied by 1, 1 multiplied by 1, 11 multiplied by 1, 11 multiplied by 1. So you will do the projection the same as the forward, okay, where you will do the inner product of the original of the basis image. So you will get 20, 12, 4, 8. So is this correct? No. Since the IRC, the input of the image is 5312. So after you do the projection and then you do the inverse transform, you should get the same as the original. But now you get different matrix. Okay. Let's look on the exercise. Okay, consider transforming a 2 times 2 images. So is transformed into coefficient of a set of basis images listed as follows. Okay, so this is the basis image. So this is the IRC, the original image. Okay, so you want to do the transformation or projection, okay, of the input image with this basis image. So then obtain the inverse transform from the previous coefficient. So if the inverse basis image are the same as the forward, okay, or so you have to do this exercise by your own using the same. Okay, let's go back to the previous example. Okay, so although this IRC is different from the one that you do the inverse, but you can simplify it by the factor. So means that if you divide each of these coefficient with 4, you will get the same as the IRC, where you will have 1 1 over 4 with the matrix of 5, 1, 2, 3. Okay. So although you can simplify it, but you are not getting the same as the original. So maybe some of the information will be lost, or maybe you will get a more brighter. Okay, since the pixel value is greater than the original, so maybe your image will come more brighter or more darker. Okay, but still the correct the image itself will be same as what is in the original. So you do the exercise. So let's continue. So there are 3 types of transformation. So that is the original, the introduction of the transformation, where you will have the IRC, okay, which is the spatial domain. So what you want to do in transformation is where you want to transform between 2 different domains. You want to transform the spatial domain to the frequency domain. Okay, so to transform it, it depends on the transformation tools that you want to use. Okay, so which you will have the WHT, the Fourier transform, and the cosine transform. But the process will be the same, where you will get the TUV by projection of the IRC with the basis image. So once you get the TUV, you want to get back the original, then you have to do the inverse process. The inverse process means you will do the projection as well, but you will do the projection on the TUV, the frequency domain, with the basis image, which most of the technique will use the same basis image, which is you use the basis image for the forward and the inverse. Okay, so forward means you do the projection, okay, or you will transform the spatial to frequency. So to the difference of this transformation is only the basis image. Okay, as been mentioned before, what is the difference between these 3 types of transformation, which is WHT, Fourier, and cosine, is the basis image. Okay, so I will go through, okay, fast. Okay, I will not go into detail. So just to show you how each of the transformation will get the different basis image. Okay, so for WHT, the basis function are based on square or rectangle with, okay, where the peak is +1 and -1. So one main advantage of rectangular basis function is the computation are very simple. Okay, because you only deals with +1 and -1. So depending on the size of the image to be transformed, we must use basis image with the right size. Okay, if you want to convert the n times n image, then you have to use a set of n times n basis images. Okay, so for example, on the previous example, where you want to transform, okay, from the IRC to the basis image. So the IRC, if it is in 3 times 3, then the basis should be in 3 times 3. So if the input is 2 times 2, then the basis image should be in 2 times 2 as well. Okay. So this is the basis image of WHT. Okay, where you will only have 1 and -1. So 1 represent as white, -1 represent as black. Okay, for example, this is 0, 1 and 0, 1. So the first one is 1, 1, 1, 1. So means that 1, 1 and 1, 1. This is 4. So once we have the basis image, we can perform the transformation. So the process will be the same. So this is the formula to get the equation of whole transform operation in given. Okay, where you will have the IRC and this is the basis image. So you do the projection, then you will get the WHUV. So WHUV is the transformation image. So when you apply inverse, so the WHUV, you will inner product with the same basis image, then you will get the IRC. Okay, so the difference between the different type of transformation is just the basis image. So each type of transform has its own equation to be used to generate the basis image. Okay, I will skip this one. Okay, this is how they get the basis image. So if it is in 1D, okay, 1D can be the first row, can be the second row or third row, or it can be vertically. First column, second column, and third column, and fourth. So it depends on how you want to do the projection. So Fourier transform is most well known and the mostly wide used transform. So it used in many applications. Okay, for this example, so it decomposes an image into a weighted sum of 2D sinusoidal term, where this is the formula, okay, to generate the endpoint 1D basis vector. So that's why they will get J, okay, negative and J. So this is the basis image for Fourier. So different to WHT, which only involve +1 and -1. So the advantage of WHT, so it is more easier. But the advantage of cosinus, okay, the image will get more better. Okay, and the last one, this is not, this is Fourier. Okay, so the last one is the cosine. Okay, so cosine also uses sinusoidal basis function. Okay, and they use only cosine function and not sine function. So this is the